in a static routing, what we have seen, that administrator were manually injecting network ID, subnet mask, and exit interface or next hop in the routing table of router. In dynamic routing, what I told you, in dynamic routing, we will run a process on router, and a router will see a routing information on the basis of that process, right? And router need these all informations to build routing table. Remote network means network ID, subnet mask, and next hop IP address, or you can say exit interface. So in a static routing, network engineer will provide these information to router, but in dynamic routing, router itself give these information to their neighbor router. Everyone clear with the neighbor router? What is the meaning of neighbor router? Means connected router. Like for R1, who is neighbor? R2. For R2, who is
R2,
neighbor? R1.
R1.
Right. So here also you can see for R1, R2 will be next hop. Who will tell to R1? R2. Right. For an example, this is R1, this one is R2. For R1, R2 is the next hop, and R2 is going to tell to R1 that bro, I am the next hop for this subnet. Okay. The reason why we come up with dynamic routing is complex to implement a static route in large network and issue of redundancy. Right. Then types of dynamic routing, distance vector. Example of distance vector routing protocol is RIP. In RIP, we have two versions, version 1 and version 2. Then we have link state and advanced distance vector. Even we don't need to discuss advanced distance vector routing protocol because it is nothing but the combination of distance vector and link state. Some properties of distance vector routing protocol and some good properties of link state routing protocols are called advanced distance vector routing. You can see advanced distance vector means updated version of distance vector routing protocol. Let's understand the properties of distance vector routing protocol first. What do you mean by distance? Distance means L3 device. Number of hops. Hops means what? L3 devices. Your router. So the meaning of distance is nothing but, for an example here, I have a few routers, R1, R2, and R, and behind R3 I have one network. R1, R2, R2. Behind R3 I have one network, let's say 10.1.1.0/24. So tell me, distance to reach in this network 10.1.1.0/24 from R3 is what? 0. Because this network is directly connected to R1, R3. So distance to reach in this network from R3 is 0. But distance from R2 is 1. It means 10.1.1.0/24 network is one hop away from R2. One hop away. Which is the distance in distance vector routing protocol? It is nothing but the distance. From R1, how many hop away this network is? 2 hop away. 2 hop away. Right? So the meaning of distance is nothing but number of hops. How many hops are there between source and destination? That is called distance. Right? Distance vector. And what is the meaning of vector? Distance equals number of hops. And what is the meaning of vector? Vector means direction. Vector means direction. What is direction in the network? What is direction in the network? Direction is nothing but the next hop. Next hop. Or you can say exit interface. That is direction. So always keep in mind distance vector routing protocol. Whatever distance vector routing protocol we have, right? For now, we have only one protocol, that is RIP. Maybe in future we'll have one more types of distance vector routing protocol, right? So all distance vector routing protocols calculate their best path on the basis of distance, means on the basis of hop count, on the basis of number of hop. And this is the biggest disadvantage of distance vector routing protocol. Why? Let me show you. Distance vector routing protocol.
Sir, can you repeat last
Yeah.
few words? Yeah.
So what I am saying, all distance vector routing protocol calculates their best path on the basis of distance. And you know the distance means number of hops. Means best path depends on number of hops. Always and always. Is it true, guys? Like shortest path is the always best path? No, it's not true. For an example, if I have a scenario like this, let's say R1, R1, R2, R3, R4, and R5. This is my network. What I am saying, this is my R1, router 1, R2, R3, R4, R5, R5. Behind router number 3, I have one network, let's say 30.1.1.0.255.0.0.0. Right? From R1 to reach in 30 subnet, how many paths are there?
Two paths.
Two paths. For an example, here bandwidth is 10 Mbps. Bandwidth over here is 10 Mbps. Bandwidth of this link is also 10 Mbps, but bandwidth of this link is 1 Gbps. Bandwidth of this link is 1 Gbps. Bandwidth over here is also 1 Gbps. And bandwidth over here is also 1 Gbps. So you tell me which path is the best path from router number 1 to 30 subnet?
Sir, bandwidth wise, 1 Gbps via R4 is best.
Via
But
R4 is the best
best
path.
path.
Means lower path is the best path between 10 and 30. Between 10 and 30 or between router 1 to 30 subnet, lower path is the best path. But according to distance vector routing protocol, which path is the best path?
Via R2.
Via R2.
Upper one.
Because distance vector routing protocol don't know about the bandwidth, about the link properties. It will never use link properties. Bandwidth, delay, load, they don't know. They know only one thing, that okay, from this side destination is 2 hop away, and from this side destination is 3 hop away. That means this path is the best path. Router 1 will install upper path in their routing table. But this is similar, like let's say between your house and market, there are 2 roads. One is this one, another is this one. Distance over here is 1 kilometer and distance over here is 2 kilometer. But on this road, you find always traffic, lots of traffic. Bandwidth is very less. Hardly one vehicle can travel at a time in one direction. But this one, the lower path, the lower road, here I have great bandwidth, good bandwidth, very less traffic. So which one you will prefer? To go market from your house?
2 kilometer one.
2 kilometer definitely, right? but the distance vector routing protocol is going to prefer this one. The reason distance vector routing protocol don't know about bandwidth. They know only the shortest path. The shortest path is the always best path.
Preferred.
This disadvantage of distance vector routing protocol. This is the reason why we are not using it nowadays. Clear now, everyone?
Yes.
Okay, this is first property, meaning of distance vector routing protocol. Second thing, distance vector routing protocol always send periodic updates to neighbor after a periodic interval of time. Now, before talking about these properties, let me tell you something about dynamic routing protocol. Now, guys, just think how routing protocol will work, how it can works. Any routing protocol, it is EIGRP or RIP or OSPF or BGP. I have two router, R1 and R2. Both are directly connected. R1 have some route in their routing table. Some route are there in the routing table. 10.1.1.0/24, 10.1.2.0/4, and 10.1.3.0/20. These are some subnets on router number 1 in the routing table of router 1. In the routing table of router 2, we have some subnet again. Correct? You know, in a static routing, manually we are going to configure routing here, but in dynamic routing, what will happen? We will configure one protocol here. So how routers are going to exchange these routes? Definitely these routers are going to exchange some messages. Yes or no? Will send some kind of message only, and that message will carry what? Network information, right? And that message is called actually update message, right? So according to the protocol, router will generate update message, right? Let's say this is update message of router 1. Update message. In the update message, it will store all their network information, 10.1.1.0/24. It might be possible that these networks are directly connected to router number 1, or maybe router 1 is learning from any other router, or maybe you have configured it statically, but these are available in the routing table of router 1. So how router 1 is going to share routes available in the routing table to router number 2 with the help of update message. It will generate update message. In the update message, it will store all the network 10.1.0, 10.1.3. This is the update message, right? After that, this is like actual information. After that, IP protocol is going to add IP header here, right? In the IP header, source IP and destination IP will be there. Source IP will be what? This interface IP address, from where it will exit this update message, from, let's say, 0/0. This is F 0/0. Here IP is dot. Also F 0/0. That is it. Dot. Right? So source IP address is going to be 12.1.1.1, and what will be the destination IP?
12.1.1.2.
It depends on routing protocol. Some routing protocol sends their update message on broadcast. Some routing protocols send their messages on multicast address. And some routing protocol can send their message on unicast as well, right? So in case of multicast, here will be multicast address. In case of broadcast, it will be sent on broadcast address, means 255.255.255.255. And in case of unicast, it will be 12 dot. Then source MAC will be there, destination MAC will be there. And after that, router 1 will forward it to router. When router 2 will receive it, it will check what is the information inside update message. Okay, these are the prefixes. router will check their routing table. Do I have these routes in the routing table? If router 2 don't have these routes in the routing table, it will learn it. It will store it in the routing table. It will store it in the routing table. Now tell me, router 1 have generated update and it have shared that update message to router number 2. Now router 2 knows all the networks of router 1. Now router 2 have these all 10 subnet in the routing table, 10.1.1.0/24, 10.1.2.0/24 and 10.1.3.0/20. In the same way, router 2 will also generate update message. It will share to router number 1 and router 1 will also have 20. Now the routing table is synchronized. Right? Routing table is same. You can see R1 and R2 have same routing table. Right? Now, should router 1 send update message again after some time? Let's say after 30 seconds. After 30 seconds, should router 1 send this update message again?
No.
Definitely no. But if router 1 is not going to send this update message again, then how router will get to know that their neighbor still have these routes? Right, let's say for an example, between R1 and R2, there is some outage for some time. At that interval of time, routers are going to remove LAN networks. So how they will learn again?
Again, update message would be sent.
How router 1 will get to know about it? That again I need to send update message. For that, routers can use a very small message, not the update message, because update message is going to carry network information, right? The length of update message is large. It will
Hello
utilize
message.
bandwidth. Routers will use lots of CPU to encapsulate the update message. Right? So later you will see the link state routing protocols are going to send one a small message called hello message, which will not carry network information. It is not update message. But the issue with distance vector routing protocol is it always send periodic update message. What is the meaning of periodic?
In after a fixed interval of time, it will
Yes.
be sending again the update message.
After a specific interval of time, it will be sending the message again and again. So distance vector routing protocol always send periodic update. After every 30 seconds, router 1 will be generating one update message and it will be sending to router 2. And router 2 will be also generating one update message and it will be sending to router number. Is another. Second type of update is trigger update. What is the meaning of trigger update, guys? Trigger update.
I have one question. So, in every update, the distance vector protocol is going to send the routes
Yes.
always.
Yes.
So, there is no hello message that you
No,
have
there is no
spoken
hello
about.
message.
And sir, if is there any node changes in network, that's also it's like
Then
it
also
will
it will be
send.
sending periodic update message. That
Oh,
is
okay,
distance
okay,
vector routing protocol is periodic in nature. Always
okay.
send full update message. Even see periodic and then full. Periodic and full. The periodic and full. Means it will carry all the informations in all the message. I will talk about the update message. To see, we have update message, update. There are two types of update message. One is periodic and second one is second one is periodic means after every specific interval of time, and trigger means whenever change will occur. For the first time, it will send update. After that, whenever change will occur, then it will send update. And then both are again categorized into two parts. One is full and second one is partial. Full update message means it will store all the network information And in partial means it will only store changed information. Mean what? It mean if I am going to add any new network on router number 1, let's say 50.1.1. So full update means in the entire update message it is going to add one new network, right? And partial means it will send update message with newly add route only. That is called partial update, right? So update message can be periodic, it can be trigger, it can be full, or it can be partial. Partial means only change information, and full means all the information.
Sir,
Right?
it also includes the deletion also, or means suppose
Yeah.
10.1.3.0 goes down.
If this will goes down,
Hmm.
if it is sending full update message, then it will remove this network information and it will send the update message.
Okay.
If this routing protocol is capable to send partial update message, then what will happen? Then it will generate update message where it will include this network only. And it will told to
Sir,
their neighbor, just remove this from your routing table. Yeah, yeah.
sir, full and partial will also be there in distance vector protocol in periodic updates as
Yes.
well.
No, distance vector routing protocol always send periodic and full update. There is no concept of partial and
Mm-hmm.
trigger. Not supported by distance vector routing protocol.
So what is the length of update message?
Depends on number of routes, no brother.
Okay.
Sir, full and partial fair in which protocol it has?
PIGRP and the OSPF.
Okay.
Clear? So see this property now. What it's saying? Distance vector routing protocol will always send periodic updates to their neighbor after periodic interval of time. Minute, guys. One important thing. See, whatever concept we are learning here, right, in the class, try to read it in book as well. Now, after learning here, if you will open the book and if you will check the properties of distance vector, right, you can understand it in much better way. Right, then you will never forget it. So what I told you, first property, it always calculate best path on the basis of hop count. Shortest path will be always best path. Second property is always it always sends periodic and full
Periodic
update
interval
message,
updates.
right? And third, loop avoidance mechanism in distance vector routing protocol. How distance vector routing protocol is going to avoid loop? For an example, before understanding loop avoidance, understand how loop can form in the topology. Loop means what? I have two router, R1, R2. Or let's say one more router, R3. On these all three routers, I have enable RIP routing protocol, distance vector routing protocol. R1, R2, right? On router number 1, I have one subnet 10.1.1.0/24. So how router 1 is going to send it to router number 2? With the help of update message, it will generate one update message. In the update message, it will store, it will carry this network information 10.1.1.0/24. Then it will forward to router number 2, and see, with the subnet there will be information of number of hop as well, right? Router 1 is going to say hop from me to this subnet is 0. Hop for you to reach in this subnet is going to be 1. So router 2 is going to store this network information in their routing table. 10.1.1.0/24 hop is 1, means that is metric, and next hop is, let's say, 12.1.1.1. Then router 2 is going to send it to their neighbor also, to router number 3. And router 3 is also going to make entry in their routing table that okay, there is one network 10.1.1.0/24 hop is 2, means metric is 2, and next hop IP address is 23.1.1.2. next hop is router number 2, which is direction. Now guys, as router 2 have sent this update message to router number 3, there is chance and definitely router 2 will send it back to router number 1 also, this update message. Or maybe it might be possible that, see, router 3 is connected with one another router here, R4. So R3 is going to send this update message to router number 4, and then router 4 will send back to router number 1. Right? So from this side also this update message can reach to R1, or from this side also this update message can reach to R1. So this is what, this is loop. Why? Because the actual originator of 10 subnet is router number 1, and now router 1 is learning it from their neighbor, same network information. So that is what? That is loop. So how distance vector routing protocol is going to avoid this loop? For each and every routing protocol, you have to understand loop avoidance mechanism. See, in the routing protocol, what you need to learn actually, the metric calculation. You know, for best path selection, we have 3 parameters. Number 1 is longest prefix match. Longest prefix match, then AD value, and then metric. So each routing protocols have their own algorithm calculation for metric calculation, right? Like, you know, distance vector routing protocol is calculating metric on the basis of hop count. In the same way, in EIGRP you will learn the formula, in OSPF you will learn the formula for metric calculation, right? Like here you can see R3. R3 is going to learn 10 subnet from two sides, from router number 2 as well as from router number 4. Both routers are going to advertise 10 subnet. Router 3 have to find which one is the best. For that, first it will check longest prefix match. So longest prefix is same, prefix length is same from both sides. Then it is going to check AD value. So protocol is same, RIP. So AD value will be also same. Then it is going to check what? Metric. It is going to check metric. So each routing protocols have their own algorithm for metric calculation, right? And in routing protocol, you need to learn the metric calculation. How that routing protocol is going to calculate metric, means best path selection. Then only you can understand path manipulation, right? Route filtering, which are the advanced concept of routing. The second thing that you need to learn in dynamic routing protocol is loop avoidance. Loop avoidance. Avoidance.
I have one question here.
Wait. Then path manipulation, and then route filtering. We need to learn these all about all the routing protocols. Yes, Anjali.
The update message that R1 is sending, is it unicast, broadcast, or multicast?
It
What is
depends
it?
on
Because
routing protocol. RIP version 1 sends their update message on broadcast. RIP version 2 sends their update message on multicast. You know the
okay.
benefit of sending update message on multicast from the broadcast? Every technology is moving from broadcast to multicast. What is the benefit?
What is RIP version 2?
CPU.
CPU utilization, right? There are two versions in RIP. First we come up with RIP version 1, then we improve some mechanism and we name it as RIP version.
RIP version 2 में क्या क्या आता है?
वर्जन 2 में राउटिंग प्रोटोकॉल है, वो भी सब कुछ आता है, देखेंगे ना हम लोग अभी RIP वर्जन 2.
ओके
अभी तो मैं RIP स्टार्ट भी नहीं किया हूँ ना,
ओके ओके
अभी तो मैं RIP के बारे में बात ही नहीं कर रहा हूँ, मैं आपको डिस्टेंस वेक्टर राउटिंग प्रोटोकॉल सिखा रहा हूँ अभी.
ओके
क्लियर गाइस?
Yes, clear. Thank you.
Now, how distance vector routing protocol is going to avoid loop? So, the loop avoidance mechanism in distance vector routing protocol is called split
Horizon
horizon.
rule.
What is the split horizon?
A split.
Like this?
जी.
What is a split horizon?
Sir, split horizon is a rule that a network which is originated from one source will not go back to that source
Very
again.
good. A split horizon is a network protocol technique that prevent routing loops by stopping routers from advertising route back to the interface that provided them. Like, this definition is not good. Let me give the receiver sends update message from receiving interface. Now, can loop form here? No, Praful. Why? Because by default, split horizon is enabled on all the interfaces. So router 1 is going to send update message to router 2 and router 4. Then router 2 will forward it to router 3 and router 4 will also forward it to router number 3. So will router 3 advertise the same update message from any interface? Never, because it is receiving update message on both interface. In this diagram also, R1 is going to advertise this update message to router number 2, and router number 2 will not send that same update message back from same interface, from the receiving interface. That is the split horizon.
But if there is not a change on R1 of on the other side, they should also send an update.
Then get your question. What is what?
Sir, his question is, when suppose if a network, one more network is added
Okay.
from on R1, so it should send it to R2, right?
Yes. Will definitely send to R2, but R2 will not send
In
same
return, R2
update
will not
message
send
back
it.
to router number 1. That is what? That is split horizon.
Parafo, but if router 1 is connected on the other side and there is a change occur, and router 2 should also send updates about changes.
Yes, definitely. Whenever any change will occur on router number 1, then it will send trigger update message. Right?
No, I mean router 2. Router 2.
Router 2.
Yes.
So
If
router
router
2
2
is
is
going to send their update message, na bro? Not the update message of router 1, na?
okay.
That is not loop. That is not loop. Loop means if router 2 is sending update message of router 1 back from the F0/0, that is loop. So what split horizon tells? Split horizon tells, do not send same update message from the interface where you have received that. That is split horizon.
Sir, what about the two interface?
Interface means
If we have two interfaces of in between router 1 and 2,
like this.
yeah, right?
So on
And
both
we are,
interface, router 2 will receive update message. On both interface, it will receive update message and it will not send back. Clear?
Sir, for loop avoidance, we have best path selection as well, right? So
Best path
that
selection is different thing. Loop avoidance means how loop cannot form, like how R1 will not receive same networks from their neighbor. Here, router 1 have a network called A. So R1 is advertising it to R2 and then R2 is again advertising same network to R1. That is what? That is loop. But after enabling split horizon, R2 will never advertise A network to R1. R2 will never advertise A network to R1. Reason is R2 is receiving a network from their interface. So from the receiving interface, it will not advertise same network. Clear? What is split horizon? But there is one issue. What is that? Issue is here I have three router. Router 1, router 2, and for an example, router 3. Three routers are there. R1 connected to R2, R3. R3 is connected with R2 and R1. Here I have one network 10.1.1.0/20. 10.1.0. R1 will advertise this network to R2 and R3. Yes or no?
Yes.
Yes. Then R2 will also advertise that to R3. It will receive update message over here. And R3 will receive it. In the update message, 10 network is there. Then R3 will also advertise to R1. Sorry, R2. And R2 will also advertise to R3. Update message. Correct? Is it loop, guys? Now tell me, R3 will accept which update? R3 is receiving update message from router number 2 also and from router number 1 also.
Shortest path.
Shortest
So
path.
from yes.
From this
Shortest path
side,
it will
only one hope is away, and from this
Yeah.
side, there are two hope, right? So this
Mm-hmm.
is the best path, and it will decline the update message from router number 2. It will discard the update of router 2. Now,
सर
yeah,
नहीं समझा सर शॉर्टेस्ट पाथ तो सर वो डायरेक्टली कनेक्टेड है ना R1 इज डायरेक्टली कनेक्टेड टू
नहीं,
R2
R3 के पास दो अपडेट मिल रहा है, एक router 1 से, एक router 2 से,
3 ओके
राइट? दोनों अपडेट
हम्म
के अंदर में सेम नेटवर्क है 10.1.1.0/24, यहाँ भी और यहाँ भी.
ओके
बेस्ट कौन सा है? बेस्ट इस
सर
रिसीव
जो
इंटरफेस पे
डायरेक्ट
रिसीव हो
R1 से
जाएगा,
R3
है
जो
ना?
R1 से R3 आ
तो
रहा
ये वाला
है
डिस्कार्ड कर देगा,
ओके
ठीक है? और ये क्या करेगा? यहाँ से अपना अपडेट मैसेज भेजेगा. Router 3 will send their update message from this, right? This is the stable scenario. Now, what will happen if this link will goes down, guys? If this link will goes down, then what will happen? The R2 was receiving update message over here. Now R2 have to send update message from here. Then only R3 will learn 10 subnet. That means that is breaking the rule of split horizon. You are sending, R2 is sending update message from receiving interface. Yes or no? So actually, you know, in this scenario, split horizon will work fine. What will happen when this network, this link will goes down? R3 is going to send update message to router number 2 with metric infinity. Metric infinity means Hope count is infinity, means R3 will inform to router number 2 that brother, for 10 subnet 10.1.1.0/24 subnet, now matrix is infinity from me. If you have learned 10 subnet from me, then remove it from your ordering table. This is the meaning of matrix infinity. And the another function of this matrix infinity can be, see, if you have any alternate path, then send to me
Please
also.
install it. Yes.
Right? And once router 2 will receive this update message from R3, it will say, okay, the matrix is infinity from router number 3 from this side, but I have one path, this path. From this side I can reach to 10 network, and the matrix is finite, 2 only, 1 only from me. So router 2 is going to send 10 subnet with matrix, then router 3 will change the path. It will store this path as a best. Again, when this link will come up, R1 will send update message to R3. It will receive update message over here. It will see, okay, matrix is lower. Again, router 3 will change the path.
And this is all dynamically.
All dynamic. And this particular scenario is called not breaking the rule of speed horizon. This particular scenario is called route poisoning. Route poisoning. Right? Here,
Means route poisoning is not happening, right?
route poisoning means whenever a best path will goes down, then router will send update message with matrix infinity. And whenever router will receive update message with matrix infinity, then from the receiving interface it will send update message. What you know in speed horizon, that router never send update message from the receiving interface. Same update message from, but if matrix is infinity, then router can send. Then router can send same update message from receiving interface. That particular thing is called route poisoning. Here you can see the route poisoning. This is the scenario, same scenario. R3 is receiving information of network A. Here in my scenario, network is A from 2 side. But R3 will store via router number 1. But if R3 will lose the connectivity via R1, then R3 will send update to R2 and mark matrix as infinity. This is not the breaking of speed horizon rule. It is called route poisoning. Properties of distance vector routing protocol. That's it. R1 is giving information of network A to R2 on fast Ethernet 0/0, and R2 will never send the information of network A on F0/0. This is called a speed horizon. But if R2 will send update on F0/0 and mark matrix as infinity, that particular thing is called route. An example of distance vector routing protocol is, this is all about distance vector routing protocol. Whatever properties till now we have discussed, that is property of distance vector routing protocol, right? Right now we have only one distance vector routing protocol. Even not only one, because EIGRP is also distance vector routing protocol only, advanced distance vector, but it is using some properties of distance vector. So these all properties are applicable for RIP and EIGRP. Here, see here, for an example, here I have router 1 and router 2. As I will enable RIP routing protocol on the interface of, first of all guys, where routing protocol works, on the router or interface of router?
Interface of
Interface of router. Okay, always keep in mind this. Routing protocol doesn't works on router, on the interface of router.
But sir, it works on interface of router, you are saying.
Yes.
But हम configuration तो globally करते हैं router में, not on the
हम
interface.
ग्लोबली करते हैं, लेकिन हम देखें इनेबल करते हैं इंटरफेस के ऊपर में. जैसे अगर मैं राउटर 1 के ऊपर में नेटवर्क कमांड चलाऊँ ना, नेटवर्क 12.1.1.0, तो राउटर चेक करेगा कि ये नेटवर्क किस इंटरफेस पे चल रहा है, उसको पता चलेगा फास्ट 30 स्लैश, सो इट विल इनेबल द राउटिंग प्रोटोकॉल ऑन F0/0.
Sir, but that time
One more
router
thing, a
CPU.
router can
So
जब
that time,
you can ask, you can ask.
yeah. So that time, router CPU also use their memory for the remembering that interface and routing.
See, interface is part of router CPU only, na bro. Interface is also part of CPU. Don't think that interface is buffer. Even buffer is also part of CPU only. Some part
But
of
with
main memory is called buffer memory.
but sometime yesterday we make some loopback also. So last time they did not use any interface then.
The loopback is also part of CPU. Loopback is virtual interface, bro. On the loopback interface also we can enable routing protocol. On the loopback interface also we can enable routing protocol. So tell me here how I can enable routing protocol. On router number 1 I want to enable routing protocol. How I can enable? Can I enable RIP and EIGRP both routing protocol here? Yes.
Yes, we can, we can.
yes, we
Yes.
can, sir.
Maybe sometime you will see on 0/0 you are running OSPF and on 0/1 you are running EIGRP. Right? Maybe on F0/0 I am running BGP, on 0/1 I am running different routing
Yes.
protocol. Static routing maybe. So routing protocol never works on router. It's work on the interface of router. Now question is how to enable routing protocol on the interface of router. First of all, by default on the router, no any memory is allocated for any routing protocol, right? And all the routing protocol is disabled. So we have to enable it by running command router and the name of your routing protocol. For an example, I am saying RIP. Once I will hit enter, what will happen? This router is going to allocate some memory to RIP. It is going to allocate some memory to routing protocol. But is RIP routing protocol running on router till now? No. Is memory allocated? Yes. Right? So this command is only going to define some memory for the RIP routing protocol. Now to enable RIP routing protocol, you have to run network command. Through network command, we can enable routing protocol on the router. Network, if I am saying 10.1.1.0, you know this command will enable RIP on which interface?
It will check that this 12.0 is configured where.
12, not 12, 10.
Then,
10.1.1.0.
yeah.
So 10.1.1.0 network is running on F0/0. It will enable RIP routing protocol on F0/, right? RIP is not enabled on F0/1. If you want to enable RIP on F0/1 also, you have to run another network command. Network 20.1.1.0/20. Now again router will check this network is running on which interface, on F0/1. Let's enable RIP. Or if you want to enable RIP on all the interfaces, you can say network again 0.0.0 means all. Enable it on all the active interfaces. So this is how we are going to enable routing protocol. In the same way, EIGRP, OSPF, BGP, all the routing protocol. In this way only we are going to enable all the routing protocols, right? So see here, I have taken one router, two routers connected with each other, and here my IP address is 12.1. Here on router number 2 12.2. Here for an example I have one LAN 10.1.1.0/24 and side 20.1.1. As soon as I will enable RIP routing protocol on F0/0, router 1 will start sending update from their RIP enabled interfaces. And after every 30 seconds it will be sending again and again. Clear? Let me show. And I am going to capture this as well.
Sir, does RIP have triggered updates?
Trigger update, yes. RIP can send trigger update also. Whenever change will occur, then it will send trigger update.
That route poisoning wala sir was triggered only, right?
Yeah. Very good. On router number 1, config T, interface F0/0, no CERT, and IP address 12.1.1.1, 255.255.255.0, exit interface loopback 1, and IP address 10.1.1.1, 255.255.255. To verify the routing protocol on router, you can use command show IP protocol. Show IP protocol. And see, IP routing protocol is not running. Routing protocol is not running. Now, you know, to enable routing protocol, I am going to use command router and then routing protocol RIP. After running this command, again I am going to run IP protocol. So IP protocol. See anything, guys?
No.
Nothing is there. Right? Now I am going to run network command. Router RIP and network 12.1.1. and exit. Do so IP protocol. Is there database?
Yes.
And you can see RIP is running on which interface?
0/0.
Slash. And sending updates after every 30 seconds. Next due update message is in 0 second, right? Now, right? Even in the capturing you can see the RIP message. Are you able to see RIP request message? Source IP 12.1, destination IP broadcast, RIP version 1. It is RIP version. By default version is 1.
1.
Apart from it, there are some verification commands like do, show, IP, RIP, database, I think. Yeah, you can use this command also to check database. Here you have enabled the RIP on directly connected interface fast Ethernet 0/0. Do, show, IP protocol is the command. Here we can check many information like the distance. AD value is what?
Default distance
120.
120.
Sir, voice clear नहीं आ रही.
अभी आ रही है?
Your voice is breaking up, sir.
Now?
Yes.
Now is it clear?
Yeah.
Right, and then you can see the hold on time, flush time, invalid time. Right, there is no any filtering till now. I have version. Maximum path that router can install is 4. And RIP is an application layer protocol, right? So if you will open the RIP request message, you can see the actual information is at which layer? At application layer. Then we have transport layer. At transport layer, which protocol?
Datagram.
UDP protocol. Then we have IP header. Then I have Ethernet header. Then same bits, physical layer. Right? And if you will check the RIP update message, see, is there any network information? There is nothing. So please keep in mind one more thing. All the routing protocol, this is not only for RIP or distance vector, for all the routing protocol, it will never include the network which is running on their exit interface. It will never include network in the update message which is running on exit interface. Exit interface is this interface. On this interface, which network is running? 2L network. So it will never carry 2L network in the update message. Which network it will carry?
LAN network, you can say.
But right now I have not advertised this network in RIP. I didn't enable RIP on the loopback interface. Let me enable it. Router, and then again network 10.1.1. For that, let me configure RIP on router 2 also. Interface F0/0, no set, IP address 12.1.1.2 55.255.255. Router, RIP, and network 12.1.1. That's it. On router number 1, I'm going to advertise and submit. Now you can see do so IP RIP database. On both interfaces, I have enabled the RIP. Do so IP protocol. Running on both interfaces. Fast Ethernet 0/0 and loopback 1, and see the capturing. In the capturing now, see the RIP message. 12.1 is sending this message. Let me open it and see which network is sending.
10.
In the actual RIP update message, you can see the information. Matric. Matric is 1.
1.
This matric for you, matric for router number 2 is what? 1. Router 1 is saying, bro, I have one subnet 10.0.0.0 and matric for you is 1. So on router number 2, we can verify the routing table. So IP route RIP. Yes, it is learning, and matric is what? 1.
1.
Matric is.
So database, can you run the command database?
So IP.
So it
Here is the receive net.
Sir,
via
metric in the sense the hop count, right?
Yes, matric is uptime. Matric in distance
So
vector routing
at
protocol is hop.
so at every hop, this metric will increase.
Yeah, when router 2 will advertise it to router number 3, it will say matric 2. When router 3 will advertise to their neighbor, matric 3, like that.
and sir, these ports are showing in capturing the source and destination. These are random ports or some fixed ports are there in capturing.
Port,
Capturing. This source port 520,
which is
destination port
reserved.
520.
This port 520 is reserved for RIP routing protocol.
Okay.
This is well known port number. But one issue is there. See on router number 1, debug IP
RIP.
after every 30 seconds, even in capturing also you can see it is still sending message. And here you can see it debugging, sending update message from the loopback interface, and soon it will send from fast Ethernet 0/0 also. But guys, loopback is what? My LAN interface, right? Here I have one switch and then PCs. Should router send update message from LAN interface?
No,
What switch will do with this update message? What this PC will
nothing.
do this update message? This is unnecessary message, right?
Hmm.
On the link, and even it is sending after every 30 seconds. See the message. So I have to tell to router 1 that, bro, this
Don't
interface
send it.
is LAN interface. Do not send update message from here, right? And that particular thing is called passive interface.
Passive interface.
Whenever you want to stop routing protocol update message on an interface, you can configure that interface as
passive interface.
so here I need to add one more command. router, SIP, and then passive interface. Here loopback 1. Now it will not send any update message on the loopback interface. But by mistaken, if you will configure F0/0 as passive interface, then there will be issue. Then router 2 will never learn this network.
Correct.
So this is one troubleshooting.
And sir, one more question. One question. अगर यहाँ पे if it would have been one more router in between R1 and R2, and उस link में अगर suppose करो, because shortest path is this, right? And if the shortest path is having some issue, physical issue, something, suppose, so can we during the troubleshooting, can we make it a passive interface, this F0/0, so that it takes on the other path via
Yeah,
R3?
sure.
Okay,
We'll see that. Okay,
okay, okay.
I will keep it in mind.
ठीक है sir.
Right now, can I move to the properties of link state routing protocol? Then again, I will come on RIP routing protocol. Can I move to the properties of link state routing protocol?
Sir,
Again, I will
maybe
come on
RIP,
RIP.
sir RIP ही practice कर ले तो आज
नहीं,
जैसे.
RIP पे फिर से आएंगे ना दोबारा.
Okay, actually fresh है इसलिए.
RIP ही कर लें आज.
हाँ जी.
फिर थोड़ा सा मेरे हिसाब से वो करेक्ट पाथ नहीं रहेगा राउटिंग प्रोटोकॉल को
तो
बहुत अच्छे से
ठीक
समझने में.
समझने का. ठीक है सर, got it, got it.
पहले लिंक स्टेट का प्रॉपर्टी देखिए, डिफरेंस समझिए. हाँ, फिर मैं रिप के बारे में
जी.
आपको सब कुछ बताऊंगा. प्रोटोकॉल नंबर, डिस्टेंस, मैट्रिक, राइट, वर्जन 1, वर्जन 2, इसकी लैब देखेंगे, अच्छी क्वालिटी की लैब, टाइमर को कैसे मैनिपुलेट करते हैं. सी दोज ऑल थिंग.
Sir, the RIP AD values,
एडी वैल्यू ऑफ रिप इज 120. 120. AD value is used to select best path between routing protocol. Because within the routing protocol, AD value will be same. So within the routing protocol, for best path selection, we have what? We have metric. Okay, wait for some time. Let me tell you some properties of distance vector routing protocol is clear. Link state routing. Properties of the first thing about link state routing protocol is link state routing protocol is going to maintain 3 separate tables. See here, distance vector routing protocol is only maintaining one table, that is their database and routing table. Is there any neighbor table? No. But all link state routing protocol is going to maintain 3 tables: neighbor table, database, and routing table. In neighbor table, it is going to store information of neighbor. Before sending the actual update message to their neighbor router, right, router must form neighborship. In distance vector routing protocol, you can see even there is no AS check, autonomous system number checks. As soon as you will enable the RIP routing protocol on the interface, router will start sending update message. That's it. But link state routing protocol are first going to form neighborship. They will check some parameter. If parameter will match, then only these two router will become neighbor. And ONS router will become neighbor. After that, they are going to exchange what? Not routing table like RIP. They are going to exchange database. Database. Right, and on the basis of database, routers are going to calculate routing. The difference between database and routing table is routing table is going to store best path only, and database is going to store all the possible path. All possible path, which is not possible in case of distance vector routing protocol. And this is the reason why distance routing protocol send update message with metric what? because they don't know about the alternate path. The alternate path is available. But guys, the good thing about link state routing protocol is link state routing protocols have complete view of topology. By checking their database, a router can design entire topology, which is not possible in distance vector routing protocol. In distance vector routing protocol, all the routers are dependent on their neighbor only. All the routing protocol are dependent on their neighbor. For an example here, R1 will advertise it to router number 2, right? Router number 4, router 4 will advertise to R5, R5 will advertise to R3, R3 will advertise to R2. So R2 is receiving 10 subnet from two sides, from router number 3 and router number 1. But it will not accept this update message, it will discard it. So router 2 don't know about this alternate path, that there is one another path available to reach in 10 subnet. So whenever their best path will goes down, they have to send update with metric what? Infinity. But in link state routing protocol, router knows, okay, this is also one possible path and this is my best path. If best path will goes down, automatically it will take this path as a best path. First think about link state routing protocol is maintaining 3 separate tables: neighbor table, database and routing table. In neighbor table it is going to store neighbor information, in database it is going to store all the possible path, and in the routing table it is going to store best path. See, in case of distance vector routing protocol, information was directly exchanged between router. But in case of link state routing protocol, router will not directly share the information. First of all, the router will check some parameter. Then router will become neighbor. After becoming neighbor, router will exchange database. And after exchanging database, router will build their own routing table. Router is never going to exchange routing table with each other like distance vector. Link state, even it is going to use link property to calculate best path. Like in this scenario, according to RIP, between router 1 and router 3, best path is upper path. But according to link state routing protocol, lower path is the best path. Because link state routing protocol is going to check link properties, the bandwidth of link. Right? And link state routing protocol is most popular routing protocol. In the production side, everywhere you will see we are using OSPF only. OSPF. Reason, it is definitely disadvantage of link state over distance vector is what? If it is going to maintain 3 table, it is going to maintain complete database, definitely it need what? More. But there is not unnecessary flooding. There is no periodic update message. After that, about the update, periodic update and trigger update. Here we have both update message. Periodic update means what? Periodic message, soon you will understand this, like which message is periodic message. Hello message is the periodic message, which is very small in size. Trigger means whenever change will occur, metric depends on link property. Routing is not done by rumors. Routing by rumors means in distance vector routing protocol, see, we have routing by rumors. All the routers are dependent on their neighbor only. Like on router number 1, I have one subnet 10.1.1.0/24. It is advertising to router number 2. So what router 2 will think? The 10 network is available on R1. When router 2 will advertise to R3, R3 is going to store it in their routing table and it will think this network is available on R2. It is not true. 10 network is connected to router number 1. Then router 1 is connected to router 2. Then router 2 is connected to router 3. And this is how router 3 is learning 10
Sir, I have a
subnet.
question. Sir, just now you told me R3 will think of that if you want to reach this 10 network, R2 it has the 10 network, but R2 it will advertise to R3 like 2 hop count, right? So R3 will think there is a
Yeah.
between two.
So R3 will think what?
There is a to reach this 10 dot network, there must be 2 hop count, right? R3 will think like this.
So
Sir,
R2 can increase the hop count. R2 can also increase. See, with the help of single hop count, how router can decide that this is not connected to router? And tell me one thing, brother. If there is another path between router 3 and router 1, will router know about this alternate path? No. That means router 3 is dependent on their neighbor only, na? If neighbor is not advertising route, then it is going to learn from their alternate path. Routing by rumors means routers are dependent on their neighbor.
So R3 will think that this 10 dot network is available on R2.
R2 only, yes.
Okay.
Router 3 will never get to know about
Outcome.
R4. That R4 can also, like I can reach to 10 network via R4 also, which is also possible. But R3 don't know about this path. R3 will be always dependent on their neighbor on R2. If R2 is advertising 1000 of prefixes, for R3 all 1000 prefixes are available on R2. R3 don't know from where R2 is learning 1000 prefixes. Right? See, later you are going to learn redistribution. Maybe on router number 2, router 2 is learning 1000 number of prefixes from OSPF routing protocol. And here we are running RIP. So we'll redistribute OSPF into RIP. So for all the prefixes, metric will be what? 1 in RIP. So R3 will think what? These all 1000 prefixes are connected to router number 2. Yes or no? Is it
correct.
true? No. So that is what? That is routing by rumor. In link state routing protocol, router 3 will have information about it. That these are redistributed route coming from OSPF domain. Even who is advertising this? Even if we are running RIP on all router R1, R2, R3. Will R3 ever understand this 10 subnet is coming from R1? No. Because router 3 don't know R1. Who is R1?
Sir, maybe it knows it, but it does not know the name.
Hardly
But
it can know
metric,
that destination is 2 hop away. Hardly router 3 can understand the destination is 2 hop away. That is
oh,
metric. Metric is 2 hop away.
but not the router ID or something. It
But
will not
not
know.
the router ID or IP address of router.
Correct.
That is what? That is routing by. But in link state routing protocol, all the router will have complete information of what the topology. Metric is dependent on link. Then routing is not done by rumors. Every router will have knowledge of entire topology. But in distance vector routing protocol, all the routers are dependent on their neighbor. In distance vector routing protocol, even we have hop limit. Between source and destination, we can have up to 15 hop. If router is receiving a route with metric 16, that will be considered as unreachable.
Yes.
Unreachable. Means in series we can connect how many routers? 15 only. But in link state routing protocol, there is no limit of what this link state routing protocol, and now you will learn more about link state routing protocol in case of OSPF when I will start OSPF.
Sir, I have answer to my question. Can I tell you?
Yeah, sure,
Yes,
sure.
just yesterday I asked you why we don't use IGPs to the ISP, right? So this because of RIP we can't use it because of the hop count, right? Because
Right.
number of routers, because 15 only, and the OSPF also has a limitation of 255 routers, right?
So see, for all the routing protocols, we have limitation of 255 because of TTL. When router is going to generate update message, IP protocol is going to add IP header, and in IP header we have one field called TTL field. Right, value will be what? 255 on Cisco routers.
So for BGP as well, you're saying.
Yeah, for all the routing protocols. When that is the
Okay.
properties of IP protocol, IP header.
Mm-hmm. Then my answer is wrong then.
Okay, but you will find your answer
Okay.
later.
ठीक है, sir.
An update I have already covered, periodic tree. And the combination of distance vector routing protocol always send full, but link state routing protocol send both. The example of link state is, then combination of distance vector and link state routing protocol is called advanced distance vector routing protocol, which is your AGRP. Advanced distance vector routing protocol has some properties of distance vector as well as some properties of some good properties of distance vector, some good properties of. That's why AGRP is also very popular routing protocol. Later you will learn there is one unique feature in EAGRP routing protocol that only EAGRP can perform. That is only and only possible in EAGRP, but not possible in BGP, in OSPF or in RIP. That is unequal cost load balance. Even if metric AD value and prefix length is different, then also you can achieve load balancing in case of EAGRP, which is not possible in
Band
any other routing protocol.
bandwidth and delays thing.
We'll see that. Okay.
Mhm.
Then, like you can see in advanced distance vector routing protocol, advanced distance routing protocol maintain 3 table. This is behavior of which types of dynamic routing protocol?
Link
Link
state.
state, right? Advanced distance routing protocol also consider hop count. This is behavior of distance vector. It calculate metric on the basis of link property. This is behavior of
Link state.
now your first routing protocol. Haven't. Okay, RIP stand for routing information protocol. It is distance vector routing protocol. It is a layer 7 protocol. Means RIP is going to generate their all messages at application layer. Okay, AD value is 120. You need to keep these all things in mind. Okay, just take one screenshot. It uses UDP port number 512. Right? And if someone will ask you what is RIP routing protocol, how you will explain? Or what is OSPF routing protocol, or what is EAGRP routing protocol, or BGP protocol? You can define these all points. Like BGP is an application layer protocol which is used to exchange routes between routers dynamically. Then we can say it uses TCP or UDP at this layer. Then we can say define the protocol number or port number. This way you can explain routing. The largest number of hops allowed in RIP is 15, which limit the size of network that RIP can support. RIP implement a split horizon route poisoning and hold on time mechanism to prevent incorrect routing information from propagated to form loop UK or from being propagated in RIP version 1 router broadcast update routing table after here is the
So you will
timer.
be sending us this document, right?
I have already this.
Okay. Okay. You said now
In the
take a snap
drive.
of this. Okay, sir.
Whatever tool I am using here in the class, you guys already have everything.
अभी ओपन करके नहीं देखा.
नाम देखिए इस फाइल का क्या नाम है, डायनामिक राउटिंग.
Okay, sir.
Now timer in RIP. Timer. First timer is update timer, means after every 30 seconds, which is the default timer. We can change it. 30 seconds. After 30 seconds, routers are going to send. And hold on time is 180 seconds. It means
It will
R1,
break down the neighborship after 180.
R1, R2. Is if R1 is advertising any network information to R2, R2 is going to store that for 180. 180 second it will store that information. Is much use. Not good. Then we have invalid time. After 180 seconds, if router 2 will not receive any update message from router number 1 for 180 seconds, then router is going to declare that network as valid. Will declare that network as invalid, but it will not flush from their table. When it will flush, remove after 240. So here I have router 1, router. Here I have one subnet, let's say X, right? So router 1 is going to start one timer for this X subnet. 1 second, 2 second, 3 second, 4 second. After 30 second, what will happen? It will receive one again update message. Again, it will reset the timer to 1 second, then 2 second, 3 second. Again, it will receive update message. 1 second, 2 second, 3 second. If router 2 will not receive update message, then timer will go to 1 to 30 second, then 31 second, then 32 second. Like this, when timer will reach to 180 second, it will declare that route as invalid. After declaring that route as invalid, router will not send data. Router will not use that X network to send data. If it is receiving a traffic where destination is X, it will discard it because route is not available. That is invalid. But still waiting for the update message. But after 240 seconds, it is going to it will remove X network information from there. Here.
Sir, can you explain hold on timer once again?
Hold on timer means, see, if I am giving you some information, you are going to hold that for how long time? That is hold on time. If I am sending you some route, right, and the hold on time in the update message is 180 seconds, it means you are going to store that in your database for 180 seconds. Here.
Yep.
Sir, in this scenario which you explained, where is that poisoning coming into the picture? Like it is discarding the packets.
Poisoning?
So route
You
poisoning.
Poisoning will
explained the
happen
concept
when
of
the physical link will goes down, bro. When the line protocol of router will goes down, it will get to know, okay, see, in this scenario, when the line protocol will goes down, it will remove the network immediately. Here I am not talking about the physical link. Physical link is still up, but it is not receiving the update message, maybe because of congestion.
okay,
Maybe
got your
someone
point.
have removed the rerouting protocol from router number 1. If link will goes down, then definitely it will remove all the received information on this link immediately.
So RIP is going to monitor the link status also?
No, that is
If
the
it is
function
not
of
monitoring,
router only. Router is checking it. Router is sending keep alive message after every 10 seconds to monitor this link. If the line protocol will goes down, it will remove all the information, all the route learn on this particular interface. Doesn't matter it is learned from RIP routing protocol or EIGRP from OSPF for a static route.
clear, sir. Thank you so much.
Right? This is one very simple topology where you can configure the RIP routing protocol. I am not going to use this one. Right? Then RIP version 1 and version. Tomorrow, I will create this lab, this type of lab where I will have multiple paths, because in dynamic routing, the reason why we are using dynamic routing is redundancy, right? Dynamic failover. So we'll create one topology with multiple paths between source and destination. Now today understand the difference between version 1 and version. The first difference is RIP version 1 sends update message on broadcast and RIP version 2 sends update message on what multicast address on 224.0.0. See, on the router, if I am going to change the RIP version, on router number 1, config T, and then router RIP, and I am saying version 2. As I have configured version 2, see something. So IP interface fast ethernet 0/0. This interface has joined this multicast group, yes or no? Which is reserved for version. Again, if I will set RIP version 1 here, it will remove this multicast group from this particular. Now, understand the benefit of sending update message on multicast instead of broadcast. Router 1, router 2, router 3, and router. Between these routers, I have one. Guys, switch always treat multicast and broadcast as same. For switch, multicast is also broadcast message. Switch R1, R2. On router number 1, I am running routing protocol, and on R3 also I am running RIP routing protocol. But I am not running RIP on router 2 and router. If I am running RIP version 1, then what will happen? Router 1 will generate update message. In the update, source IP will be maybe 12.1. Destination will be what? Broadcast. Let me talk about destination only. 255.255.255. Destination MAC will be also what? Broadcast. All F.
Broadcast.
Router will forward it to, which will
Switch.
forward it to all the routers.
All the interfaces.
When router 4 will receive this update message, at which layer it will receive? At physical layer. Physical layer is going to convert it into frame. It will hand over to layer 2. Data link layer is going to check destination MAC. Destination MAC is broadcast. It can be for me also, right? If the destination is broadcast, then definitely it will decapsulate the frame and it will check layer 3 information. At layer 3 also destination IP is broadcast. It can be for me also. It is going to check layer 4 information. At layer 4, what is destination port? 512. Yes or no?
520. 520.
Router 4 will get to know, no, this is not for me. It is not running. Yes, router 4 is going to discard it. Correct? At which layer? At layer 4. Means router 4 will decapsulate the frame at layer 2, at layer 3. At layer 4 also it will check the information. After that, it will discard. After every 30 seconds, it will be discarding one update message. Router 2, same thing. Router 2 will be also receiving one update message after every 30 seconds. It will be decapsulating at data link layer, at network layer, and then at layer 4 it will be dropping the packet. But router number 3, RIP is running there. Router 3 is going to process the update message, it will learn some routes. Now, if I am going to change RIP version 1 to RIP version 2, here version 1 to version 2, what will happen now? Destination MAC. Now, what is destination MAC or destination IP? 224.0.0.9. On this corresponding MAC like IP address, router is going to calculate MAC address, multicast MAC address. Then it will forward to, which will again forward one copy to router 4, router 2 and router 3. This time when router 4 will receive the traffic at layer 2, it will check destination MAC. Destination MAC is multicast. Router is going to check, am I member of that multicast group? Is my receiving interface member of that multicast group? No, because RIP is not enabled here. So this interface is not member of 224.0.0.9. It is going to discard it. At which layer? At layer 2. Router 2 is also going to discard it at layer 2. And router 3 will. This is benefit of sending a message on multicast instead of here. So that's why this is the first improvement in RIP routing protocol. First improvement in RIP routing protocol. Clear? Hope it is. Second difference is RIP version 1 is a classful routing protocol. Now what is the meaning of classful routing protocol?
Sir, 8, 16, 24, 32,
Yeah.
basically.
Class. Remember the class of IPv4 address. IPv4 we have what? Class A, class B, class C. For class A my subnet mask is 8. For class B my subnet mask is 16. For class C my subnet mask is 24. So we have fixed number of IP addresses. Here we have 2 to the power 24 IP addresses. Here we have 2 to the power 16 IP addresses. Here we have 2 to the power 8 IP. This is what class full. But nowadays we are using what? Classless. Because according to our requirement, maybe my network length is 100. I need only 100 number of IP addresses. I can use classless network. Means maybe /25 is classless. And nowadays we are using what? CIDR value. Classless interdomain routing. Right? So your RIP version 1 does not support CIDR. Means subnetting. It does not support subnetting. It will always consider 10.1.1.0/24 as 10.0.0.0/. Right? It will always consider this /24 as it. Right? But RIP version 2 support classless routing. Here can configure the LSM, can perform the subnetting. Subnetting is not supported by RIP version 1. Subnetting is supported by RIP version.
So /24 is class C subnet mask, right? So how come it will not support class C class full?
10.1.1.0/24. This one.
Okay. Yeah, got it. It's /8.
Class A. Right? It will check first octet value. First octet value is 10, means class A. It will use subnet mask default 255.0.0.0. Right? So it will consider this network as 10.0.0.0/8. Right? So here is the second improvement in RIP version 2. It is classless routing protocol. And RIP version 1 also does not support authentication. But RIP version 2 support MD5 authentication. Here we can configure security. Right? So we can say RIP version 2 is secure routing protocol, but RIP version 1 is not secure routing. That the difference. and drawback. Drawback of RIP, hop count, metric, which is distance, closest, the best always, slow in convergence. You can see by default after 180 second router is going to declare a prefix as invalid. See, R1, R2, R3. Here I had one subnet 10.1.1.0/24, and router 3 is going to learn 10 subnet through RIP routing protocol 10.1.1.0/24. Right. For an example, I have removed this network from here. I have removed this network from here. When router 3 is going to remove it from their table, guys, after 180, means for 180 second router will be still forwarding traffic towards router number 1 for this destination. This is convergence, very slow convergence. Right. R3 is connected with R4. Now I have removed this network from here and I have added this network here. Right. So it will take minimum 30 seconds to convert the topology. Right. After 30 seconds, it is going to receive update message from router number 4. It will check metric. If here metric is lower, then this path will be. But still it will not flush the older entry immediately. It will flush older entry after 240 seconds. That's why we are saying RIP is slow in convergence. Fourth problem is periodic update message, which can increase the network traffic. And the fifth issue is routing by. तो अब इतना कौन बर्दाश्त कर सकता है?
करा है सर पहले.
तो नहीं था. Nowadays we have so many options. So why we will? But still, you know, in the small organization, you can use RIP routing protocol. Sometimes some companies are still using because it is so simple to use, configure, right? Troubleshoot.
Correct, sir.
To manage OSPF, definitely you need good engineer. Right? तो कभी कभी होता है ना कि मैनेजर सोचता है यार मैं ही सारा काम कर लूँ, तो वो फिर क्या करेगा? वो RIP routing प्रोटोकॉल चलाएगा.
Correct.
तो नेटवर्क का वीडियो देखेगा.
अब
So okay. After that, second routing protocol is EIGRP. But before starting EIGRP, we'll do one good lab of RIP routing protocol for your hand. The reason why I am teaching you RIP is, see, just to make you understand the concept, so that I can teach you link state routing protocol in better way and advanced distance vector routing protocol in better. That's it. Otherwise, RIP is not in our syllabus as. But if you know the properties of distance vector routing protocol, easily you can understand properties of link state routing protocol. So that's why we will see basic route filtering also in case of RIP. Guys, how many of you know the ACL, access control list? If you guys don't know the ACL, then before starting the dynamic routing protocol like RIP configuration, I would like to cover first ACL, access control. Then I will, because I'm going to use it, ACL, in the route filtering. At the same time in routing, I'm going to teach you path manipulation, route filtering, and the troubleshooting. Right? So if you guys have basic knowledge of ACL, already basic knowledge of ACL, then no worry, then we can cover it later After the routing, we will see the ACL. But otherwise, if anyone is thinking, no, I don't know anything about ACL, then first I will cover access.
Sir, पता है, we
I
know
mean,
it,
it
but
doesn't hurt
not
for you to teach it.
fully.
You can teach it if you want.
Then, sir, in that case, we have to learn prefix list as well, right? थोड़ा सा डिफरेंस है सर।
सब एक ही सिक्के पे है।
जी जी।
हॉट मैप भी
एग्जैक्टली तीनों चीज एक ही दिन में हो सकती है।
okay. So fine, then tomorrow we'll start lab. Today you can configure this type of lab. Daughters, you can enable rerouting protocol, then you can verify the database, you can configure passive interface, you can check the routing table, you can check the reachability, you can try to change the timers, try to play with timers.
Sir,
Sir, it's possible to share this document to us. This
Sir,
PDF.
DNS3 I am okay.
sir, एक क्वेश्चन है, it may be stupid, but can we use suppose on one router we can use RIP version 1 and on another version 2, and will they form the neighborship?
Answer में
जी।
router 1 के ऊपर में क्या चल रहा है रिवर्जन
2 पे वर्जन 2 चल रहा है थी, सर देख लेते हैं।
तो पर
पाइप सेक्शन RIP
1 पे वर्जन 2
वर्जन 2 जी।
और 2 पे वर्जन 1 वाईपी प्रोटोकॉल क्या बोल रहा है what it's saying default version. By the way, we have 3 version in RIP. One is default version, one is version 1, one is version. So default version can send update message to version 1 and can receive update message from any version. Here default version can send update message to version 1 and can receive update message from any version, but default version cannot send update message to version 2. Can receive update message from version, that means default version 1 is default version is compatible with version 1, correct?
Correct.
And version 2, what it's saying, it can only send update message to version 2 and
Version
it can
2
only receive
and
update
receive
message from version
2.
that means it is
Not compatible. Correct.
if version must be on router number 2 also I have to configure. So IP route यहाँ पे तो route आ रहा है, यहाँ पे route आ रहा है, क्यों आ रहा है, क्योंकि यहाँ पे क्या चल रहा है default version and default version can receive update message from any version, can receive update message from any, but if I will set version 1 router and after some time is going to so IP keep
सर एक बार क्लियर मार के देख लीजिए।
टाइमर दे, ये टाइमर 21 पे आया ना, ये 31 पे चला जाएगा, 27 29 30 ऐसे 30 पे रीसेट हो जाना चाहिए था ना, क्योंकि नहीं हुआ रीसेट। तो अब ये
अब
240 सेकंड के बाद क्या कर देगा, प्लस यार
सर 180 सेकंड बाद करेगा ना?
180 सेकंड के बाद तो इनवैलिड डिक्लेयर करेगा ना।
ओके
After 180 second it will declare this is invalid. It will not flush. Flush time is 240 second, you can see.
करेक्ट।
Invalid time is 180. कोई काम
चला
fine. So here I have to configure what? Reversion router. Sometime interviewer can ask you these types of questions. Like on one router I am running reversion 1 and on another router reversion 2. Can these two router exchange routes? Answer is no. अब क्या हुआ? अब 30 सेकंड
30 सेकंड्स लेगा सर। स्लो कन्वर्जेंस वाली चीज।
That is on router number 2 I am going to advertise 20 network router RIP network 20.1.1. So IP ट्रिगर अपडेट का सीन ही नहीं है। There is no trigger. Back in face look back. 1 to perfect. Now can I ping 20.1? 20.1 source and .1.1. So IP route 20.1.1.0. ऐसे आप detailed information. Now this way you can check the detailed information. For this network you can see slash value is what? 8. But the configure slash value is what? So run interface look
स्लैश
back 1.
प्लस सी।
But here fault. And distance value you can see none from rerouting protocol, distance, metric.
बट सर ये क्लासलेस को सपोर्ट करता है ना? यू
You
टॉक
have
दिस
to
राइट?
configure, you have to disable automatic summarization. So IP, see,
नोट और समरी राइट?
automatic network summarization is in.
Perfect.
So if you want to disable it, you
Not
router, skip, and no auto
समरी।
history. So IP out.
आई थिंक क्लियर करना पड़ेगा। आ गया
दोनों है ना, ये वाला रिमूव कर
जी।
देगा। After some time it will remove this one. So if someone will send traffic now for let's say 10.10.10.10, it will forward to router number 1. It will forward traffic to router number 1 because it will match. What is the capturing? The capturing you can see it is sending ICM. Destination IP 10.10.10. Still entry second.
मे बी ये वही चीज 240 सेकंड्स तक रखेगा फिर फ्लश करेगा।
नहीं 180 2 मिनट हुआ है ना अभी तो 120 सेकेंड।
Mm-hmm.
180 सेकेंड के बाद राउटिंग टेबल से हटा देगा, डेटाबेस से 200 आफ्टर 240 सेकेंड इट विल रिमूव फ्रॉम द डेटा। 2 मिनट 20 सेकेंड 4 सेकेंड 25 सेकेंड 30 31 32 33 33 4 5 6 7 40 4। अब आ गया है टाइम 4 6
Sir, तो
मतलब राउटिंग टेबल से कब रिमूव करेगा। अब क्या बोल रहा है यहाँ पे,
possibly down.
अब ये ट्रैफिक नहीं भेजेगा। देखिए
Here,
क्या,
so I am bereaved. So yesterday I couldn't join the class at all. Do you have the recording left? And then if you give any lab work, do you have, where can I find the lab?
रिकॉर्डिंग इज ऑलरेडी अवेलेबल, गो थ्रू इट।
So do you have the labs?
yesterday there was a lab of static routing ना।
No, no, no. Yes, that's what I'm saying. I couldn't attend the class. I joined for a few minutes. I am bereaved, so I had to travel. Did you send a document for the labs?
which
Sir,
lab
what we
brother, I didn't,
sir is saying that did you give as a homework for performing lab?
yeah I will give you the lab, not now. Now it's not required. Now you can take few routers and you can configure like I am configuring. Your first lab is here for the reporting protocol lab.
Yesterday there was only IPSLA and static routing.
Sir, what we can do is as a request, up on daily basis you can give us a lab and
For static routing, these are the lab.
Is it part of the documentation you
Already
sent to
available
us?
on the drive. You can check,
Sir,
go through
this
it.
document is not available, sir. Check, sir.
Available.
Yes, sir. Hmm.
So that when I watch the video, I can practice the lab. I mean, after my
This
getting my.
document is not available in the drive, sir.
Here is the lab of
Today we will discuss
42 lakhs per
find this
annum.
file.
Wow, 42 lakhs, that's your salary?
Yes.
And what do you do?
I'm an
And I will share this lab guide to you.
Okay.
for static as well, please.
The lab for, here is the task 1, task 2. the configuration is going to be, for a static also I will share the lab. For a static I had already given you one lab in the video. Lab was like this. 4 router was here. R1, R2, R3. That's it. Here I have one LAN, here I have one LAN. Request should go via router number 2, reply should come via router number 4. This was the lab for a static.
And this can only be done in DNS3, right?
So when you will go through recording, you will get this lab there.
A few days is going to be rough for me, but I will be watching the recording.
And I am sending you
Requested to access for
lab access.
recording.
Yeah, there's no link for it.
Tell me one thing. Is there anyone who don't have access of this folder? Folder?
Let me check.
सर इसका है जो ये
सबके
बाहर
पास है,
आपने अभी
सबके
खोला,
पास.
Yes, sir. Yeah.
तो इसमें लैब्स कहाँ है फिर?
अगर कोई ऐसा है जिसके पास इसका एक्सेस नहीं है तो मैं
I have it.
anyone don't have access of this folder, sending you. अभी यहाँ
सर लिंक कहाँ भेजा है व्हाट्सएप पे?
चैट में भेजा है इस गूगल मीटिंग. एक तो लैब आपको इसके बुक के अंदर में मिल जाएगा.
Yes, sir. In the lab is not, sir.
The dynamic routing folder
Okay.
I have used today in the class. Here also we have one lab for version 2. And this is, here is the lab for a static routing configuration. Even configuration
This
is
can be done
there,
in packet tracer.
but you can check configuration for RIP. For RIP, I think lab is okay. For RIP routing protocol, EIGRP, OSPF, day by day I will be uploading lab guide. Same lab you need to perform by yourself in GNS.